Uh, the all of the questions in question in quiz number 2 basically relates to combustion analysis, trying to come up with the formula, and then the molar ratio and the limiting reactant and things like that. So I think it's question number 4, where magnesium reacts with chlorine. And that question, my intention was actually giving you a simpler question to begin with, but the past experience, not just everybody here in this class, in this semester, the past experience is that people tend to overthink it a little bit too much. I'm asking you to balance the equation first, and if you look at that equation, magnesium react with chlorine, give you magnesium chloride. The reaction is already balanced. So 1 mole of magnesium will react with 2 moles of chlorine. And the question is asking you how many grams of magnesium will react with 2 moles of chlorine. Well, 2 moles of chlorine will require 2 moles of magnesium. So basically I'm asking you to convert 2 moles of magnesium into grams. Your conversion factor is atomic mass. So that is the intention there is that you understand the molar ratio between the 2 reactants, and if you know how many moles of one reactant you have, you can determine how many moles of the other is required. But you got to go through that. I mean, the key thing there is that figuring out the molar ratio isn't really the most complicated thing, because if you balance the equation, the molar ratio is already given. You've got to be able to do conversions between grams to moles, moles to moles, moles to gram. That detour we showed you there, if you have grams of reactant, you got to convert it into moles. And then between the molar ratio of each reactant, or between that particular reactant to the particular product that we're looking for, you convert it into moles. Okay? So that's without the need of determining the limiting reactant. If you have the mass of the reactant converted into moles and taking into consideration between the molar ratio, for the molar ratio between that particular reactant and the particular product that we have there, using the molar ratio as a conversion factor, we will be able to convert it into moles of product. And then once you get the moles of product, you can convert it back into the grams of product. And most likely the question is given to you, the quantity is given in grams. So you have to go through, you have to be able to go through that gram to mole, mole to mole, mole to gram conversion. Each step, and there's a different conversion factor there, either atomic mass or molar mass of the compound, and then the molar ratio. So an example that we run in class in chapter 4, that on that PowerPoint there, and whenever you do stoichiometry questions there, the limiting reactant is always something that you need to keep in mind, because especially when you have 2 reactants there. Unless you see the word excess, you got to figure out between the 2 reactants who's going to run out first, because when one runs out, you won't be able to make any more product. So the one that runs out first is the one that you use to determine the amount of product that you can actually get. So one of the approach, if you look at question number 6, I believe, in the second quiz there, it's the ammonia reacting with oxygen gas, giving you nitrogen monoxide and I guess water, and that's the product there. Okay, so in that case, we give you 8 grams of ammonia, 17 grams of oxygen gas. Now you can't use grams directly. You've got to convert 8 grams of ammonia to moles, 17 grams of oxygen to moles. Okay, molar ratio, the molar mass is the conversion factor. Now once you get them into moles, you can see every 4 moles of ammonia will generate 4 moles of nitrogen monoxide, NO. So that's 1-to-1 ratio. Okay. Every 5 moles of oxygen will only generate 4 moles of ammonia in the balanced chemical reaction. So that's 5-to-4 ratio. Taking that ratio, molar ratio in consideration, what you want to do here is that you can say, well, based on 8 grams of ammonia, we convert them into moles, and each mole of ammonia will produce 1 mole of NO. So whatever number of moles of NH3 that you have, you will end up with the same number of NO. And then you convert 17 grams of oxygen into moles, and then every 5 moles of oxygen can only produce 4 moles of NO. So that's 4/5. That molar ratio is your conversion factor between the number of moles of oxygen to the number of moles of whichever give you the smaller number of moles. That's going to be the limiting reactant. So you have to make sure whenever you don't see the word excess in a stoichiometry question, and when it involves two or more reactants, you have to figure out who's going to run out first. And just so you, many people are asking this question is because you still need to do a little bit more practice in order to understand what you need to do to set up the equation. Once you understand how to set up the equation, it's really not that complicated. And although each step of calculation takes time, so a question like that may consume a lot of time, and you got to be able to get to the point where you can do it quickly, because tomorrow in the exam you won't have a whole lot of time to think, how do I set this up? When you're given the question, you know how to set it up, and you go it quickly. Even that, you may not even have enough time. You may not have enough time to do all the questions here. So that's something that you want to go through. In the PowerPoint on chapter 4, we did run an example: 21 grams of zinc, 19 grams of HCl. You got to figure out who's going to run out first. Whoever runs out first is the limiting reactant. And you use the amount of limiting reactant to determine how many grams of chloride you can get. So make sure, if you have questions about the limiting reactant, make sure you go back and review that question again. And if you still have questions after reviewing that example, and for that example, in the end, we actually set up the equations. One side is using zinc, the other side using HCl. Zinc is in red, HCl is in green. So two different colors there, and we're looking for how do we figure out the number of moles of, or grams of zinc chloride that we can get. So that is an example. Pretty much all of the stoichiometry questions are very much similar to that type of, to that particular example. So make sure you go through that, and if you have questions, please talk to me and see me today during my office hours, and because in your tomorrow's exam it's going to be at 8 o'clock, and so if you send me an email after my office hours today from 11 to 12 and then 3 to 4 today. So if you have questions when you're working on things there, and make sure you come and talk to me. And if you send me a message after 4 o'clock, you may or may not be able to get a message before tomorrow's exam. So try to take a look at those problems again, and then remember quizzes due tomorrow, and also we're going to have our second exam. The second exam covers chapter 3, 4, and 5. Okay. Now, I wish I could spend more time in talking about whatever we have already covered, but looking at the schedule there, we are seriously behind already. I don't know how this happened. I thought I was on schedule, and all of a sudden we're probably about half chapter behind there. And we'll try to make up whatever we can today. So expect to be here a little bit longer than the regular Monday, Wednesdays. And so we're going to continue our discussion in chapter 6 and the learning objective number 3. Now in chapter 6, we're talking about the energy aspect of the chemical reactions there. So we're trying to quantify the amount of energy either needed for the reaction to happen, or the amount of energy that will be released when the reaction is finished to the environment. So in the first learning objective, we give you a lot of definition. What is work? How do we define energy? What is exothermic reaction? What is endothermic reaction?